Alright, good morning, algebra. So we're gonna look at one more little skill from this unit before we do, I think a couple days of reviewing everything is gonna be helpful. So those of you who are concerned or confused, we are gonna get to some reviewing some stuff before we go too far deeper, but this is just be kind of the last sort of new-ish thing before we spend some time really making sure we're okay with everything. So this is something you might have seen before when you learned how to multiply using, well, the distributive property. So think about this diagram and think about why this shows that this quantity, 6 times 3 plus 4, equals this. Like, how do you get this from the diagram? So this over here is what's called an area diagram. And it's called that because it is a diagram of a shape with area. That rectangle has an area of length by width. So the area of this little piece up here is 6 by 3, so it's 6 times 3. There are 6 times 3 blocks in here, and in here it is a 4 by 6 rectangle here, so it's 6 by 4. So really the whole area is 6 by 3 plus 6 by 4. And it also equals 6 times 3 plus 6 times 4. And it could also be the whole side length is 3 plus 4. So it could also be 6 times 3 plus 4. All right, and this sort of idea of these two expressions being the same is where a lot of our math's going to come from today. It'll start off easy, like a little bit more weird, but we'll probably spend our first live lesson, or second live lesson, whenever it is. Whatever happens next week, we'll probably spend some time reviewing this and reviewing other stuff from the unit. So make sure you get specific questions ready for that. All right, so try to draw a diagram that shows that 5 quantity x plus 2 equals 5x plus 10. And try to follow your ideas from up here. Give it a pause, give it a minute. It should look something like this. So I just drew my rectangle right here, pretty much mimicking the one above. 5 is my width. And my length is x plus 2. So I can split it up into two rectangles, one with a width of x, with an area of 5x, and one with a width of 2, and the area would be 5 times 2, or 10. All right, so there's our first little piece of the lesson, and our goal is really to make sense of these area diagrams when dealing with quadratic functions. All right, so we're going to look and see a couple more examples of this. We're going to really be focusing on these diagrams today. Hopefully it's not too bad, and hopefully the math later on isn't too bad either. Okay, so down below we are actually going to explore some vocabulary that's a real flashback from September. Applying the distributive property to multiply out the factors of or expand 4 quantity x plus 2 gives us 4x plus 8. So we know the two expressions are equivalent, or we're equivalent expressions. We're going to be writing things equivalently. You can use a rectangle with side lengths x plus 2 and 4 to illustrate the multiplication. So it's kind of like what we've been doing up above. The side length is x plus 2 and 4. So my area is 4x plus 8. All right, so we're going to make sure we have a little quadratic one down below. So draw a diagram to show that n by 2n plus 5 is the same as this. Show that those two are equivalent. All right, so again, practice. Try to draw a diagram like this, or try to draw two diagrams if you can. So I actually had you draw two diagrams if you could on a whim, because I realized that there's two very legitimate ways to draw this. So I could think of this as n as my width by 2n plus 5. So if my side length is 2n plus 5, I can split it up into 2n and 5. Because I don't know what 2n plus 5 equals. So I can't just like say it's like some number. I want to split it up into pieces to decompose that number. And over here, I can split up that 2n even more, because that gets me 2n. So I could split up into an n by n, an n by n, and an n by 5. I'd get an n squared, and a 5n. And n squared adds to give me 2n squareds. Because this is really saying I have two n squareds. Get rid of that term. I have 2 of n squareds. So I have 2 of them. All right, it's not saying you square 2n. That's not what it's saying. It's saying you have 2 of these. All right, and then you add 5 to that. So lo and behold, this must be equivalent to the area of an n times 2n plus 5 rectangle, because this was n times 2n plus 5, because that's your length and that's your width. All right, that's really our whole goal here, just practice doing that. So here we can just practice using the distributive property, distributing that first number across the parentheses. Shouldn't be too bad. Might get a little bit strange with your terms. We have to use some quadratic terms. And just remember, if you get stuck, you can consider drawing a diagram. I'm going to draw a diagram for all 4 of them that you can reference. Focus. Focus. There we go. So then, sorry, I wasn't telling you guys to focus, which is the first. If you get stuck, consider drawing a diagram. I'm going to draw you a diagram for each one anyway, so that way you can refer to it. Okay, so hopefully distributing wasn't bad. Hopefully you were able to do that okay. So if you were not able to do it without the diagram, you can go back through and just remember what the distributive property looks like. We're going to be complicating it later today, so I hope you enjoyed it while it lasted. So yeah, 6 times the third n gives you 2n, 6 times 2 is 12, p times 4p is 4p squared, p times 9 is 9p, 5r times r is 5r squared, 5r times 3/5 gets you 15r over 5, or just 3r. You have calculators available, you may use them, but also notice the 5 as the multiplier cancels out the dividing by 5 in the fraction, so it would just be 3r. 0.5w times w, 0.5w squared, 7 times w, 7w. You could have drawn diagrams for all these. It looks like this. This one's extra, this one's super extra. I don't know what I was thinking. This one's good, that one's good. They're just all messy. All right, this is a good one to do handwritten versus online, which I wasn't thinking about before I did it, but now I'm glad I did handwritten. Just a few more kids said they liked the handwritten one better. Most of you are no preference, but a couple of you said that handwritten was the way to go. So, anyway, let's complicate things. Ready? Okay. So here is a diagram we are going to use. And I know what you're thinking. It looks more complicated, but it also kind of looks like a Punnett Square. And to be honest, it kind of is like a Punnett Square. And I know that some of you, when you mentioned that a while ago, that it looked like a Punnett Square in math. And that's good. We're going to keep doing them. It wasn't that bad. So, here is a diagram of a rectangle with side lengths x plus 1 and x plus 3. And we're going to try to show that this expression is equal to x squared plus 4x plus 3. So they're the same thing. So give it a try. And actually, before you do that, we're going to try all 3 of them together. So we're going to try to figure out what the equivalent expression of this is and what this is. And before we do that, I just want to say that this x plus 5 squared is not x squared plus 25. That is not a thing that's going to happen because that's not how exponents work. What this really means is that I have 2 x plus 5s being multiplied, x plus 5 and x plus 5. So I'm going to see what that diagram looks like, what that area diagram is, all right? Think about that as the length and that as the width. All right, down here we got length and width. So give those a try. Okay, so for our first one, we notice that our first box is an x by x, so it's x times x, or x squared. We have a 3 by x, so 3x, an x by 1, so 1x, and a 1 by 3 gets us just 3. So we have an x squared term, we have 2 linear terms, so a 3x and an x, and a plus 3. So the linear terms you'll find can often be combined, so I get x squared plus 3 plus 1x is 4x plus 3. And I'm only writing like this because it'll maybe help you notice something a little bit later when we start not drawing area diagrams, because can you imagine drawing this, showing your parents what math you're doing? You'd be like, I'm drawing squares to multiply numbers, and they won't like you anymore. Or no, I'm sorry, they won't like me anymore. So anyway, we're gonna try to know some patterns so we can simplify this stuff. So, yeah, for part A, again, x plus 5 by x plus 5. That would get us an x squared, an x by x squared, an x by 5 is 5x, an x by 5 is 5x, and a 5 by 5 is 25. X squared plus 5x plus 5x plus 25. And I'm just adding all these pieces together to get us the total area. That's what we're really doing, is finding the total area of that entire thing. And then I get x squared plus 10x plus 25 is my final result there. And then over here, I didn't finish it. I started play too early. X times 2x is 2x squared. 2x times 4 is 8x. So that gets me 2x squared plus 8x. And that's my answer there. That's an 8. All right. So we've looked at area diagrams for how to simplify expressions with one factor outside or just a simple term outside. And then we've looked at how to multiply expressions to get two. Like we've just multiplied a quantity or a sum by another sum. That's pretty impressive, pretty weird. And we're gonna look at sort of how to sort of simplify that for ourselves in the future. So we're gonna try a couple more of these. We can try the diagrams, or we can notice something. We're gonna notice something right here. We'll try it right now. So here we see we have 2x plus 1 and x plus 3. All right, so I'm gonna draw the diagram with you. Let's see, that's my length, that's my width. And if you want, this could be the very, very last diagram you draw, if you're really confident. So length is 2x plus 1. 2x plus 1. And then my height is gonna be x plus 3. So I'll make that a little bit shorter, that a little bit longer, whatever. It's not drawn to scale, Mr. Robot, relax. Okay, so there's my diagram. So now I want you to notice where each of these squares fits in up here. So I'm gonna do them all in different colors. I know this is what you've all been waiting for, is all the different colored pens. I know, me too, I'm so excited. So, I just have to find them all because they've scattered. Well, I have 4 black pens. That's gonna be useful. We'll see. Okay, so we have 2x times x gets me 2x squared. So we multiplied x by 2x first. So really what it is, we multiplied this by this. All right. And then we can multiply, I only have 3 colors. I have 7 pens and 3 colors. So then I can multiply 2x by 3 and get 6x. So really now I'm multiplying the 2x by the 3. And now I'm multiplying the x by the 1. So I have 1x. So I multiplied the 1 by the x here. And now my last option's not very good. Okay, well, I'm gonna use a blue Sharpie, so I'm just gonna have to deal with using purple again. So now I'm gonna do 3 times 1, and that gets me 3. And so here again, I multiplied my 1 by 3. So if you noticed, actually, let's do the adding first. So we got 2x squared, then we have x plus 6x, they're like terms, plus 3. So 2x squared plus 7x plus 3. So if you noticed, we sort of distributed both. That was not an H, dude. Okay, both numbers across. So we multiplied 2x by x and 2x by 3. And then we did 1 by x and 1 by 3. All right, so it's kind of like doing the distributive property twice. And when I tell people that, they're like, yeah, okay, that makes sense. I'm distributing both numbers. So down here, I know there's no numbers. It's very sad, I know, but you can do it. So we're distributing both numbers. So we're gonna do x by x and get x squared. And then it's x times n, and I get xn. And then I'm going to distribute the m. M times x is mx, and then m times n is mn. All right, so now I distributed both numbers there. And I could draw a diagram, and I guess I might as well do it. If you don't want to see the diagram, you can fast forward like 2 seconds. Almost done anyway. So then we'd have an x squared, we'd have an xm, we'd have an xn, and we'd have an mn. Or you could write nm, doesn't really matter. So that's our real diagram. So we don't have to do a diagram anymore because we can just distribute both numbers across. So I should try the following 4. Try it without a diagram. Try to just keep track of all your numbers. You should have 4 terms before you simplify, all right? So keep track of that. Okay, so as you can tell, I did not draw any diagrams. I just wrote out all my expressions, and even better news, I found my green pen. So then I'm just going to simplify this one real quick because I didn't do that. So you have all our answers. X squared plus 6x plus 2x plus 12 simplifies to x squared plus 8x plus 12. 2x squared plus 20x plus 50 simplifies over here. X squared plus 9x plus 14 down here. And then over here we had 12x squared plus 19x plus 5. All right, so that's all of our real. And that's what we're doing today. All we're doing is learning how to distribute twice, distributive property twice. So I hope that wasn't too bad. Just to sort of summarize, I like these notes. I threw them in on the back so you could look at them. But basically, we can define a quadratic function by many different expressions that look different but look the same. They are equivalent. So like in an earlier lesson that I might not have even shown you, we can, I think I skipped that lesson. We'll go back to it. We could write something like this, and it could also be distributed and written like this. We could write those two things the same way. And the first one shows that whatever it is, revenue is the product of these two terms. And the second one shows that it's the difference of those two terms, but they represent the same type of thing. We did it with an area diagram, so that was hopefully helpful to sort of visualize it, but we're going to sort of try to not do that because it takes up a lot of room, and it's hard on a computer because, well, good luck with that on a computer. And really multiplying these two things gives the area of a rectangle, and you really decompose it into 4 different pieces. So the first thing we want to do is multiply the first terms together, and then multiply the outer terms, the outside terms, and then we multiply these 2 inside terms, multiplying 2 by the x because now we're distributing the 2. And then multiplying the last terms together, so the 2 and the 3, the 2 last terms. So this is a sort of a key that people sort of give out to sort of make sure that you've multiplied everything you're supposed to multiply. It only really works with the 2 by 2s, but it's FOIL, which is the word foil. So people have called it foiling. It's really just distributing twice. It's not really any crazy new stuff. So yeah, if you want to keep that in mind, make sure you use FOIL to multiply each thing by the next term, because it's really distributing that x across each of the products. So it's distributing the x across that, and then it's distributing the 2 across that. And then that turns you into this. All right, so good work, and best of luck.